to talk to you about a parallel between two seemingly unrelated industries. That is actually the health food industry and sustainable aviation. At first glance, these two things seem worlds apart, but if you look closer, you'll see there's some striking similarities in their marketing battles and infrastructure challenges. I'll start with the health food industry. The first thing I want to say is that the most direct competitor to the health food industry is the fast food industry. So I've got a little thing up on the screen here. So fast food chains have perfected the art of marketing their products against the wishes of dietitians and health experts. They use a particular meal and they say that it's synonymous with attracting the youth to celebrities like Travis Scott and Megan Thee Stallion. And they say that by saying, get the Travis Scott meal. Get the Megan Thee Stallion meal. You can eat just like a celebrity. And this is a powerful marketing strategy that overshadows the health warnings issued by dietitians, and the messages often seem boring and underfunded in comparison. And so, despite this awareness raised by the health classes and storytelling like the 2004 documentary Super Size Me, which was highlighting the risks of fast food, the industry has not only survived but thrived. Fast food chains spend millions of dollars marketing their industry and perfecting their image, leveraging their vast infrastructure to ensure their dominance. They have a head start that a few healthy restaurants can even match. On every corner, there's a fast food outlet, a testament to their deep-rooted presence in our lives. Now let's turn our attention to aviation. That's why we're here, right? Here we face a similar challenge. The sustainable aviation community is akin to dietitians, promoting their message that is crucial for long-term health of our planet, but lacks the same level of funding and marketing prowess as the fossil fuel industry. So you see two images here. You have one from a fossil fuel company, and it says, we're keeping it flowing. And they have a head start on all of this. In the other image, you have Usher, or from Atlanta, Usher, doing the Super Bowl halftime show afterward. He said, I'm coming home to Atlanta. And he did a nice little video for Archer Aviation's platform. But first, let's acknowledge the crucial role that fossil fuel companies have played in supporting energy needs for over a century. They are not the enemy. I know some of you don't want to hear that, but they're not the enemy. Their dominance in infrastructure and extensive marketing budgets have indeed contributed to the overuse of fossil fuels. But they have also powered our economies, supported our growth, enabled global connectivity. This extensive infrastructure and established presence are both a strength and a challenge. Fossil fuel companies have fulfilled their corporate responsibility by serving as the backbone for modern energy consumption, but the time has come for this planet's occupants to uphold our personal responsibility to meet the needs of the present without compromising the ability of future generations to meet their own needs. We do this by diversifying our energy sources, ensure energy resilience, or the capacity to adapt and recover from supply disruptions, including resource exhaustion. Resilience should be our target in the aviation sector, helping us avoid awkward geopolitical relationships and preparing our global economy to pivot when one form of energy begins contributing to inflation. We want people to get to work, buy groceries, and go on vacation. Sustainable aviation offers a way to keep that going with some balance. Much like how consumers gravitate toward fast food for its convenience, the aviation industry remains entrenched in its reliance on fossil fuels due to established infrastructure and consumer habits. For aviation to achieve long-term viability, it must reduce its reliance on fossil fuels by embracing sustainable energy solutions. This is that and not or gimmick that's being put out by the fossil fuel industry. It's marketed pretty well, but the transition is akin to shifting dietary habits from unhealthy fast food options to healthier choices. It requires not just technological advancements, such as electric and hydrogen-powered aircraft, but also a concerted effort to change ingrained habits and perceptions. On a personal note, just as my family and I enjoy meals in fast food restaurants in moderation, We must approach our use of fossil fuels with the same judicious mindset. It's perfectly fine to have a cheat day and indulge in fast food occasionally as long as it's done wisely. Similarly, I drive a hybrid vehicle because currently it's impractical to meet all of my traveling needs without fossil fuels on the East Coast. This balanced approach is the key to transitioning smoothly while maintaining our respective lifestyles. Now, I had to put this slide up here, unfortunately, a few weeks back, but we have to invest in sustainable technologies and improve regulatory frameworks to encourage the adoption of eco-friendly practices. We face significant hurdles in infrastructure and market readiness, much like the challenges seen with universal hydrogen's unsuccessful attempt to take off, sometimes literally, but mostly figuratively, due to financial and logistical barriers. So in conclusion, this is where G.I. Joe meets Captain Planet. That's me, right? In conclusion, breaking the fast food paradigm in aviation is no small feat. It requires a collective effort to innovate, invest, and ultimately change our habits. The stakes are high, but the rewards, a sustainable and resilient aviation industry, are well worth the effort. So let's take some inspiration from the fast food industry's success in marketing and infrastructure and apply those lessons to promote a healthier, sustainable future for aviation. You cannot shame people into investing in sustainable aviation. So in the likeness of that, I have a sustainable infrastructure panel, and we look at things that span across 5 domains: land, air, sea, space, and cyberspace. Within those domains, we have these 4 perspectives. You have a research laboratory perspective, you have industry, you have academia, and then you have the government perspective. And so, very happy to be able to present to you all the Sustainable Infrastructure Panel. If you all will come on up. First one here representing air is Mr. Rex Alexander. Thank you, sir. Mr. Hugh Curtright, representing land perspective and others. Ms. Amy Smokes Geschwell, she's representing cyberspace and representing both sea and space. We have Chris Pink Sheets Lowe. Thank you very much. All right, I'll stop marching around so much here and I'll start talking. So, Rex, I'm gonna let you have the floor if you'll go ahead and let us know a little bit about 5 Alpha and some of the things you do.
Sure.
Thanks.
Thanks, Juice. So, Rex Alexander, I own and operate a company called 5 Alpha. Helicopter pilot by trade, more than half my life. Our company designs and develops infrastructure for vertical flight, primarily heliports for helicopters, but back in 2017, wound up working with Uber Elevate. I was the head of infrastructure for Uber. Started working in the advanced air mobility, vertical takeoff and landing environment, and have been in that space ever since, working with NASA, FAA, ICAO, and several of the other organizations, trying to figure out exactly what is advanced air mobility and what's the infrastructure need to look like. I also work with a group called the Vertical Flight Society, used to be the American Helicopter Society International, and have been with them since 2018 as their infrastructure advisor.
Awesome. Mr. Hugh Curtright, you represent land here, but my understanding is you do more than just that, don't you?
Broadly, yes. Although I'm an aviation enthusiast, I have no real background in, professional background in aviation. I started out in economics and urban regional development and transitioned that into being a Marine Corps intelligence officer. A long time ago, just when I thought I was getting that career in line, we found ourselves in Iraq and Afghanistan, and we weren't getting the results we thought we were going to get from the way we were thinking. So the community spent a lot of energy learning how to think again and learning how to break problems down differently and starting to look at things holistically. And that's what I'm trying to bring to this panel, is that holistic perspective. We've all heard the example, somebody that buys an electric car and they say, oh, I'm going to help the world and help society by driving an electric car. And then you start asking them questions. Well, where are you getting your electricity? Is it coming from an electric coal plant? Maybe you're not helping the environment as much as you think. What about all the metals and such in the car? If they're coming from prison labor, maybe you're not helping the world as much as you think. So if you're not looking at the problem holistically in a different way, you may not get the answers or solutions you're really looking for. And one of the examples here, we're using Ocracoke Island on the Outer Banks for our study. Naturally, we all know the Wright brothers went there to test their airplane because there's lots and lots of wind there. So one would think, holistically, that's a great resource to generate power on the island of Ocracoke. But if you look at other aspects, North Carolina is not exactly leading the charge for renewable energy, and the county of Harlow County is not exactly, they're not fans of windmills. They won't let any go up in the county. So you have this resource that sounds really valuable, and here it can't be used because you haven't looked at it as a whole problem. So again, that's what I'm trying to bring to the panel, and currently I work at the Marine Corps Warfighting Lab looking at the future of operations largely in the Pacific as a individual contractor. Thank you.
Wow. So, Ms. Amy Smokes Geschwell.
Hi, I'm with Semper Sky and I do cybersecurity. So aviation traditionally hasn't had a lot of cybersecurity need. They have their own bandwidth of comms. But as we see more of the electronic systems go on systems like the Edge or 5G, I'll be here to help make sure all of that goes on secure.
Awesome, thank you. Chris Pink Sheets Lowe.
Hello, everyone. I am a maritime space officer with the Marine Corps out at 1 Marine Expeditionary Force Information Group in Camp Pendleton, California. In my past life, I was a surface warfare officer on a guided missile cruiser out of Japan for a couple years, and then came over to the Marine Corps to have done some aviation command and control, and now I do space. A lot of what I like to look at is like policies that help enable sustainable infrastructure, maritime and space-wise.
Awesome. So let's talk about optimization. Rex, could you lead the discussion for that, please?
No, on the optimization piece, we talk about sustainability and we look at infrastructure. When we design infrastructure, we try to design the infrastructure for optimization because optimization equals efficiency. Efficiency then equates to sustainability. And the problem we run into in the electric environment or the hybrid electric environment is we're trying to design to the optimum performance, not the maximum performance. And that's one of the challenges we run into in developing infrastructure. Site selection is a huge issue in that we're looking to make sure that we're giving a location, the aircraft is not required to perform at maximum efficiency or maximum performance. It's allowed to perform at maximum efficiency. Because if we're in the vertical development world entirely too much, we're burning a whole lot more energy than we need to burn. And that's where we get into site selection, is where's the best place to put infrastructure. There's a lot of interesting theories out there in the advanced air mobility, urban air mobility world as to where to put infrastructure. And I can tell you it's a multi-layered question because what makes it great for one instance makes it terrible for another instance. So when I look at infrastructure, I look for where's the best place to put it. That may not be in close proximity in an urban environment because if I do that, it may actually create a situation where to get in and get out, you're expending a significant amount of energy to get in and get out vertically. I'm trying to spread you out horizontally for maximum efficiency. So you're burning the minimum amount of power to get in and out of my infrastructure. Because if I can do that, my sustainability is higher because now you're not burning nearly as much energy, you're not demanding as much energy off of the grid, and you're not creating a situation where we have a lack of energy for the population. If there's one thing that you'll find is the people that live in a neighborhood are not going to like you if you're using all their energy and they're having a brownout because of you. Now, if I can spread the infrastructure out, put it in locations that allow for shallower approaches and departures where you're more efficient, all of a sudden now your energy demand is dropped. The caveat to that is if you use less energy, that is actually equated to extended range. If you're in the vertical all the time, your range is going to decrease significantly. So that it's really behooves us to look at infrastructure at multifacets. Environmental is a big piece of that. Winds, turbulence, site selection, footprint, all go into selecting good infrastructure.
You know, I think you made a great point. And since we've been using a couple of terms a few times, we've said sustainable and we said renewable. I don't know that we've really defined those. So As far as we're concerned, sustainable means that you meet the needs of the current generation while not hindering the next generation. So notice that when I say that, I'm not saying 3 generations from now. This becomes very important when you have to make decisions about what to keep or the dimensions of something or how much energy to use. Renewable means that during a human lifespan, that form of energy can be used again. So for example, the sun's energy is renewable, right? For example, using thorium as a form of nuclear energy for propulsion, that might be sustainable, but it's not going to be renewable. So just to make sure that we level set and define that, I want to make sure I did that. So Hugh, do you have anything to add about infrastructure in general?
Well, infrastructure is, of course, what makes a site viable for flight operations, but it also has to integrate with the local community. I mean, if they want it right downtown, certainly there's going to be some customers that have that need. And the cheaper we can make it, the more people are going to want that specific thing, which makes it very hard to build supporting infrastructure for it. But it's also got to navigate local compliance. I heard somebody this morning talking about there are a lot of people in Silicon Valley that know how to make things fly, but they don't know how the FAA works and how to get it certified. And that was one of the roles they saw for AIAA in the future. That's just the top level, the federal government. We've also got to worry about local government, the local power sources. I mean, are they going to be able to supply what you need? Are they going to be able to supply the kind of labor you need, people with the right skill sets? And is this community economically viable enough to make your operations profitable?
Yes, indeed. Yes, indeed. And Smokes, I was going to, ask you about the cyberspace environment. One of the things that we notice is that we're getting more electric aircraft, and with that, we're changing voltage, and we're going from maybe 150 volts direct current DC, and we're kind of moving up to over 1,000 volts. And when we do that, we're actually creating an electromagnetic signal that can interfere with signals around, like a military base or other aircraft present, the aircraft itself with other systems within it. And I was wondering, when you are working on cyberspace solutions for aviation, with the understanding that you're just now getting into aviation, is there anything that you've seen from other domains or from other folks that are working on, like making their network more secure? Are there anything that we can look out for and be more cognizant of as we pursue sustainable aviation?
Likely the radius of impact of signal, right? So if you're sending out your own signal, you want to have a lot of towers and keep the trajectory or length of communication signals shorter. So having more to saturate the need instead of having to travel long distances would probably be your best bet to lay a net of effective communication in the safest way possible.
Awesome. So Pink Sheets, you're a fellow Marine, so I got to toss you some curveballs, right? No. So when we are thinking about these 5 domains, land, air, sea, space, and cyberspace, you are representing, or you have experience in both sea and space. Can you help us understand why we need to pay attention to sea and space as we are looking for solutions and infrastructure in aerospace?
Well, I mean, a lot of it, like the other year when the Suez Canal got blocked, and that disrupted supply chain issues throughout the entire world for months on end. I mean, maritime-wise, we ship most of our fuel, dry goods. It's easy to do it with air, it's quick, but if you want to do a lot of it on the cheap, you have to do a lot of cargo tankers. And then space as well is just, space is has a little finger in every pie, from the navigational system and spreading out the time clock that makes everything run to, just in general getting that GPS to get you from A to B. And it's just really important, at least infrastructure-wise, I think, especially coming up, is making sure we have redundancy and resiliency to make it a sustainable infrastructure. We're in the 11-year high for solar activity, but back where I am in California, we have power lines failing because they have 70-year-old clips keeping these high-powered lines together, and then, it finally breaks, snaps, catches fire, but then we're expecting a lot more environmental activity to start, not really intentionally attacking, but again, further degrading our infrastructure system, and we just need to get that resiliency and redundancy up before something significantly degradatory happens.
I think you made a good point about something. You talked about like kind of old infrastructure, and then when that breaks, what you do. And sometimes we come up with like new things, and just like car parts or anything you can relate to. You put the old with the new, sometimes you start having problems, right? And one of the things that we're noticing, that we talked about in our infrastructure subcommittee, was these different adapters to some of these sustainable aircrafts that are electric powered, some are hydrogen powered, and they have different size adapters. The manufacturers, the original engineering manufacturers, OEMs, they came up with different sizes for adapters because they weren't really concerned about what the other OEM was doing. And so as a result, when we look to provide infrastructure in the form of a battery energy storage system or a start cart, for an aircraft or anything that can help charge it, we have to first think about, hey, do we have this adapter? What size is it? And then we have to order that. And so I don't know how much the audience has had experience with, say, their phone and their phone charger. And since you're in the audience here, hey, raise your hand if you've had a phone that had to have a different charger, and you got frustrated because why can't you just use the charger that was there previously? Yeah. So the same thing is happening. I see lots of hands up right now. The same thing is happening in sustainable aviation where, through no fault of the original engineering manufacturers, they've decided that they were going to make something a certain way because, as Rex was saying, they were trying to maximize the performance of the aircraft at the expense of the location where they want to launch from, and that can create problems. So that means you have to perform at your max capability every time you fly. And we're human beings, and we're fallible human beings, and that's just not going to fly literally and figuratively, right? And so something to think about are these different connections, et cetera. So speaking of the infrastructure subcommittee, we talked about we have all these different domains, and within these domains we have these different perspectives, right? So across land, air, sea, space, and cyberspace, we have the perspective of government, academia, industry, and then you also have research laboratories who are kind of like this in between. They have things that they care about that are somewhat different. And so when we're looking at that, we realize that infrastructure is all over the place. And how could we focus this in? So we came up with a design reference mission. And I was hoping that somebody on the panel would be willing to kind of share that design reference mission. Hugh, go for it.
You're talking about the scenario for the...
Yeah, the scenario, DRM.
So the scenario that was given to the students in our challenge was to make a more sustainable, aviation-friendly total infrastructure for the Ocracoke Island in North Carolina on the Outer Banks. Rather than asking for a realistic, we're going to do this over the next 10, 20, 30 years, we gave them a scenario where there was a lot of government money being thrown at the problem, and they wanted an overall design that would utilize the resources that were being given to them in still a phased approach, but much more rapid than you might believe would be realistic in today's environment. So it was kind of to supercharge the process by pushing them to develop this with additional resources being thrown at them.
Mm-hmm. So basically, lots of conflicts started happening, and we made this up in the scenario. So we just took all the things that were happening in the world, and we said, okay, everything just hit the fan at once. So you have things going on in the South China Seas, things going on in Europe, everywhere but Antarctica, pretty much. And temperatures were flaring amongst different nations. and created a situation where the United States and its allies had to address these conflicts. And so in doing so, they needed lots of fossil fuels to do their job. And some of those resources, just like you would have seen in, say, World War II, where you had to ration resources and everything else, they realized that they wouldn't be able to sustain the amount of fossil fuels that they were using in the continental U.S. And service all the different needs of the military services, et cetera, and the allies. So they decided, the government, to do a National Renewable Energy Initiative, NREI. And this is all part of a scenario, so this is made up, just to be clear. NREI was established to say, okay, we're going to bring together government, industry, academia, and the research laboratories, and we're going to find a way to use other energy besides fossil fuels while these different conflicts are being addressed. And so it brought all of the different perspectives together among the domains. And then the government said, hey, we want a design reference mission, or DRM for short, to bring everything together. And we want to do a test bed. And we're going to use the Ocracoke Island off the coast of North Carolina, as Hugh said, as our test bed for this. And the point in all this is just to bring everyone together thinking about things, and when it's time to make a decision, how tall should this tower be? How big should this battery be, this airframe? It's all based off of the design reference mission. So I'm going to welcome questions to the panel, but our findings from looking into this as a subcommittee, we would meet bi-weekly and discuss this. One of the main things that we figured out is that you can't just focus on one domain of energy and say, okay, I'm just going to look at aviation, because you're going to end up missing something. So we welcome your questions, and I also wanted to see if you had anything more you wanted to add about infrastructure. Rex?
I think what Hugh said is a big challenge, in that local perspective is a huge issue in acceptance. We'd asked a lot of people who lived in the LA area, would you be interested in writing an eVTOL? And pretty much everybody said, well, of course, that'd be great. Would you be okay with us? We put a vertiport in your neighborhood, and not so great. So there's a challenge there when we look at building infrastructure, and that public acceptance is going to be fun.
Mm-hmm. Yeah. So what can we do? So we'll just use the design reference mission, where we're working on an island. We're sort of using an island as a nice laboratory, a microcosm of a larger city, where we can take the lessons learned with less impact to a population before we decide to put it somewhere on a mainland or in a major city, for example.
I think the biggest thing we can do is lessons learned from our history is public outreach, mm-hmm. public education, but at the same time, we have to make the public a stakeholder and get their input and make sure that when we do something, they have a dog in the fight, if you will, mm-hmm. and they help guide the decision-making for their municipality. Then I think we can navigate that minefield much, much better.
Understood. Okay. So coming in as an outsider to an island or any sort of locality, you're going to have a hard time trying to get anything accomplished, mm-hmm. Because it looks like you're just there for a cash grab. Mm-hmm. So I'll give you a scenario that when I talk to the when I talk to the folks of Ocracoke Island, I actually went and visited there. You can only get to this island by boat or by plane. And when I talked to the folks there, they expressed a couple of things. One, we don't like change. I was literally told that we don't like change. All right. And the other thing is, however, we only have a health clinic here, and we have all the time someone slices their hand working on a boat, or someone got bit by a shark, etc. They reach that golden hour. They really need to get care, and they need a quick way to get from that island to the mainland to a hospital. Otherwise, they start to fade. And so What can we do for them with sustainable aviation? One of the things that we found was that a sustainable air medical transport business works really well for that particular scenario, that particular island. And that would enable folks to get from the island to the mainland, in about 30 to 45 minutes tops. And you're leaving from the island instead of what they currently do, which is there's a city called Pitt Greenville in North Carolina, and there's a medevac helicopter. And if they're not servicing someone else who has an emergency, it takes them about 45 minutes to an hour to get there once they get in the aircraft. And then once they get there, they'll be able to administer some aid. But by that time, you're pretty critical. You've reached almost the end of the golden hour. So those are things to consider. Another thing that we talked about from the space perspective, there was some virtual reality talk, almost where you could use some sort of, we were talking about satellites that would enable some communication. And with a stable connection, you can don some augmented reality goggles and say you're a PhD for medicine. So a medical doctor, MD. And you could, worst case scenario, talk someone through how to save someone's life who just went through something life-threatening. So these are some of the things that we talked about during the panel that I wanted to bring up. But I also wanted to see if there was anything else before I open it up for questions.
Anytime you get a test bed and you have a community that's willing to take on this challenge, it's really important to realize, why was it that these communities in LA didn't want this in their backyard? What is it they don't like? So is it the noise? So let's make sure in a test bed, we want to make sure we measure the noise, right off of the heliport, 100 meters out, half a mile out. Is that, how much noise are we really talking about? Because very often people are saying things, but if it's louder than a fire truck, I don't want it. Well, maybe, what if it's not? Well, we have to find that out, because we don't have the answer to all that. As you were talking about the space domain and the cyber domain, what communications are we going to need? We've got to push a lot of data both to the aircraft and to the airfield. How's that getting there? If what's in place now is not sufficient, where have we got to add things? And make sure that all these different domains, again, are matching up expectations. But when we go to educate or to ask other communities, hey, do you want to do this? Is this not just commercially viable, but would you accept this in your backyard? We're actually able to tell them, hey, we have done this. It's not just make-believe. And this is how much noise we're talking about. This is the probability of an accident. All those things that are legitimate concerns. But right now, we just don't have a lot of data to give them.
Yes, and what's been very helpful is having Smokes look at things from her cybersecurity perspective when it comes to aviation. One of the things that we wanted to do is, hey, is there some sort of large language model that we can use to gather the data we need in order to find the optimal place to set infrastructure? Is there a way that we can develop the workforce so that they can deal with certain things that they weren't dealing with before when it comes to fossil fuels like high voltage electric, et cetera? But I see a question here for Rex. It says, can you elaborate more on Uber Elevate? What might have been done better? Maybe the inclusion of short takeoff and landing aircraft?
There were a lot of great things came out of Uber Elevate. When I was working with Uber in that spectrum, they then decided to change their business model and sold all their assets to Joby Aviation. But I think in the beginning, one of the challenges we ran into in that business model was they wanted to control everything. They wanted to operate the aircraft. They wanted to own the infrastructure. They wanted to run the operations. And in that piece of having everything under one roof, municipalities were a little resistant to that because it was so specific, it was not agnostic. So if Uber were to fail, could I then have another agency come in and take up? Or would I have to retool all my infrastructure to the other aircraft, to the other operation? And I think that was one of the things when we looked at that whole vertical lift piece with Uber, they wanted to control every facet. And you can't do that. Municipalities are not interested in talking to you if you're the only operation that they're going to do business with and you fail. They're on the hook for a lot of money, and that in the municipality world, in the state world, translates to votes. And that's the quickest way to get kicked out.
Yes, you can have a scenario where, we'll use Oak Island again since it was part of the scenario. You have these folks who are from like Nantucket, very wealthy. They come to the island, they buy up a bunch of property, raise the value of the property so the inhabitants or the people who live there can't even afford to live there anymore. A natural disaster happens, they collect, the kind of folks who are not from there, they collect the insurance money, they leave, they don't rebuild. And they just pretty much leave those localities in shambles. So that being said, there's another question here. How can we best address not in my backyard? I'm gonna open it up. Hugh, I think you talked a little bit about this before, kind of like being cognizant of the people who live in a locality. And Rex, you've talked on that. Is there anything we want to say to expand on that from anybody in the panel?
I think we've been kind of dancing around it with different comments.
Yeah.
It's the political environment. Mm-hmm. Is that what people want? Is it economically viable? I think education and outreach really is the answer. Mm-hmm. A lot of people don't know what they don't know, and they're scared of it, and they're not curious. How do you get that information out there?
Yeah.
If only there were an internship program out there.
Well, I think the other piece of that puzzle is the average person in the municipality that you're dealing with, that you're trying to help. Any given day, they're putting out a fire that they didn't expect that day. So they're dealing with things that have nothing to do with what we're dealing with. So they're putting out fires that deal with homelessness. They're putting out fires dealing with electrification issues, fires in the neighborhood. So that's constantly. They don't have time to learn this information. We need to take it and condense those white papers down to something that's understandable, that we can boil down to something they can learn quickly. And I think that's one of the things when we look at the municipality leaders, those are the people we want on our side to help educate the people in the public. And you got to take into account what their day looks like on any given day and adjust your tactics.
Okay, looks like we got time for one more question before we go into the next segment. It says, how do you convince the government to not highly tax people who opt for sustainable choices, since the government will lose tax as fossil fuel use decreases? It's very relevant. This is, a lot of airports make money from fuel tax and from, some of the services they provide. So when you take that away, again, just like the fast food paradigm, there's infrastructure already in place. And when you kind of pull the rug on that, you're also affecting people's jobs, their livelihoods, their investments, et cetera. Mm-hmm. So how do you convince the government not to highly tax people? I want to open it up to anybody on the floor.
And we're seeing this a lot in different states that maintain their highways by gas taxes, and they want to transition to electric vehicles. What taxes are the electric vehicles paying? They're not contributing to the upkeep of the highways that they're using. Mm-hmm. So that the government has to have a certain amount of revenue to provide the services that people want. Mm-hmm. Where do they get that? Sure, we don't want to overtax something and drive them out of business, but somehow, whether it's the airport or the roads around it, and that's got to come from somewhere.
Okay. We're a little over time, but I'd like to address these couple questions, and then we'll make sure we'll wrap it up. So the next one is, how can we sustain, finger quotes, the development of sustainable aviation infrastructure when political priorities are always changing? Well, may I take that one?
You may.
I believe that when it comes to politics, hey, I'm a small business owner. I'll be honest with you, as a U.S. Marine, I've never really cared for politics. What party you're with, whatever it is, when you come and fight with me, I want you to have my back and I want you to know I have yours. So, but because you're a small business owner, you have to pay attention to that because the jobs of the people who work for you are at stake. And so, in my opinion, what you have to do is you have to create a product that people actually want. And so the closest thing that I see that we have right now in the sustainable aviation sector is advanced air mobility. Because you are able to, some of that traffic and everything, you can circumvent or you can get around some of that by using these new forms of aviation. And so when you're using that, just like a taxi service gets taxed, for having a taxi service, that might be where some of your revenue can come from instead of fuels. No, it won't be as much. And initially, when you start working your infrastructure, weaning yourself off of fossil fuel uses, heavy fossil fuel use, there will be a heavy price. But when the smoke clears and your subsidies go away from the government, you have to have a product that people believe in. And I believe that right now, just like the Model T Ford, right, that Henry Ford made, did he invent the automobile? He did not, right? What he did was he made the automobile more affordable so that not just the wealthy elite could have it. Everybody could potentially get an automobile. And so they wanted a faster horse. They got the automobile, and it was something better. And so the consumer wanted it. And so just like the diet industry or health food industry versus fast food, the same thing has to happen with sustainable aviation, where you have to offer a product that is better, that gives the consumer more. So that is, in my opinion, what you can do. Now, I'm going to do this last question here, and then I'll do push-ups for my interns who are going to come on the stage soon because I hijacked some of their time. So the last one is, there's a serious lack of infrastructure education. How do you get youth interested and passionate about infrastructure? Amy?
With apprenticeships and internships, the program, much like you have, and offering it to people in direct-to-work kind of situations where you are training them for a specific set of skills that doesn't need such a broad range degree, as a requirement to get in.
Yeah, and who's going to be implementing or actually using this infrastructure that we build over the course of several years, if not our youth? So on this note, could you all please give a hand to the Sustainable Infrastructure Panel? Thank you. Appreciate you all. I'm sorry for going over on you, but we got some interesting questions toward the end. So next thing I want to do is I want to turn toward the folks who will actually be implementing anything that we come up with right now, okay? So we had a competition. Thank you very much. We had a competition, and during this competition called the Sustainable Island Challenge, we had 28 applicants that applied for this challenge, and they formed about 7 teams. We whittled it down to 4 teams called the Final Four, and within that Final Four emerged the winner. And just so you know, some of the universities that were interested, Michigan State University, University of Michigan, Virginia Tech, Arizona State University, Arizona, Kennesaw State University in Georgia, Mizzou, St. Louis University, University of Virginia, if I didn't say that already. So out of all of those different schools and students who applied, the winners emerged, and they're going to present to you their Sustainable Island Challenge design. And at the end of this, you get to vote on whether that design is worthy of a modeling and simulation, or if we need to go back to the drawing board and continue to refine. So I understand that for some of you who are systems engineers, you want to see all these documents. I want to see the P-spec, the performance specification. I want to see the design reference mission. I want to see all this data. But this is do the best you can with what you have. And so without further ado, I've got the winners. They're pronounced studs. And studs stands for the first initial of each of their names. So you can see that A is upside down and they pronounce it studs. So you all come on the stage, all right? Everybody give a big hand. Okay. Thank you. So with studs, last night, these are Semper Sky's interns. So every internship that we do, we have a call sign review board, okay? So we're not talking about nicknames, we're talking about call signs. And this is the first layer of security. If you're ever out abroad, for example, in the military, and you're flying and you're in enemy territory and you don't want them to know your government name so they don't go looking you up and looking your family up, you have call signs, right? So we're not doing it for that reason. It's just flat out fun. So there's only 2 rules. 1, you can't make your own call sign, and 2, no mean call signs. So I'm going to introduce each person here. So Daphne Savas, call sign Poe. All right. If you want to know what these call signs mean, you're going to have to get them a cold beverage at a restaurant of their choice. Okay. We have Sydney, call sign Yups. That'll be fun if you ever get to figure that one out. Okay. And then we've got Aiden, call sign Twinkles. We've got Savannah, Taki. And then we've got Taka Suzuki, call sign Raptor. So I'm going to hand the clicker over to you, and the floor is yours.
All right, does this work? Awesome. Great. That's great to know. Good afternoon, everyone. We are Studs, as we have just been introduced, a group of 4th-year aerospace engineering students from the University of Virginia. And we are very excited to be here with you today. We first want to thank the team at Semper Sky for making this huge opportunity possible for us. And we also want to thank the AIAA and you guys for having us here at this wonderful conference. My name is Daphne Savas, and as a little introduction, one of my passions in aerospace is space and aviation infrastructure.
I'm Sydney Bakir, and in the future, I would like to work on automotive engineering and aerospace engineering with a focus in sustainability.
My name's Savannah Hafer, and my passions really lie in space and patent law and energy development in the aviation industry.
My name is Taka Suzuki. I am particularly interested in hypersonic air-breathing flights and materials for hypersonic applications.
And I'm Aiden Winfield, and I'm interested in the development and design of unmanned aviation vehicles.
Where'd it go?
It is switching, but
Oh, okay.
yeah.
Sorry, guys. Okay. So today we will be going through our introduction and scope with you on our Island Design Challenge. We will then tell you about our infrastructural domains with the implementation of sustainable practices. Following that, we will tell you the timeline we came up with for the possible implementation of these, and conclude with our performance and conclusion and introduction of standards within Ocracoke Island.
So kind of give a little introduction of what we were doing. We were tasked with designing and implementing a sustainable infrastructure necessary for Ocracoke Island to be completely self-sufficient and sustainable. Now, for the larger scope of when we were working towards this, we were using Ocracoke as kind of a model to kind of see the applications that we could apply to mainland USA. Now, when we were really looking at it, we did focus a lot on making sure that the people at Ocracoke were happy, because just like the US, there are so many cultural, community things that make Ocracoke exactly what it is, home to so many people. We wanted to make sure we weren't stepping on anybody's toes. So ultimately, our design was primarily focused on aviation domains: air, land, sea, space, and cyberspace. Taking each, we created sustainable and resilient implementation models for execution while accounting for environmental impacts, economic effects, well-being of the community, and more importantly, the longevity for future generations.
As we navigate through challenges of climate change and environmental impacts, the aviation industry stands at a crossroads. Sustainable aviation has emerged not just as a buzzword, but as a necessity driven by global awareness and technological advancement. So why does it matter so much? The traditional aviation industry has been long associated with significant carbon emissions and environmental impact. However, with the realization of these challenges, sustainable aviation aims to mitigate these effects by reducing carbon footprints, optimizing fuel efficiency, and exploring alternative energy. Its purpose extends beyond mere compliance with regulations. It strives to ensure that air travel can coexist harmoniously with our planet's ecosystems for generations to come. Okay. With sustainable aviation gaining significant attention today, many have already begun addressing the pressing issue. However, when our team decided to tackle sustainable aviation on Ocracoke Island, North Carolina, we noticed something that was missing. How can we combine other domains to focus on aircraft and make the transition seamless? Realizing this gap, our initiative focuses on establishing the fundamental elements essential for sustainable aviation to thrive, specifically on Ocracoke Island. This involves not just mitigating immediate environmental impacts, but also integrating sustainable practices across air, land, sea, cyberspace, and space. By collaborating closely with local stakeholders, embracing cutting-edge technologies, and advocating for supportive policies, we aim to position Ocracoke Island as a leader in the sustainable aviation. Our goal is to create a future where air travel harmonizes with the island's natural beauty and ecological balance.
Ocracoke Island, North Carolina, is more than just a location to its inhabitants. It's a way of life. The few but proud waterlocked occupants have spent generations developing unique customs, activities, and even their own dialect, hoi-toid English. The 9.6 square mile island is home to nearly 800 people and is just a small fraction of the 200-mile-long string of peninsulas and islands that make up the Outer Banks. The average age on Ocracoke Island is relatively aging at 47, which could cause some issues and concerns of health care because there is no hospital on the island. Although tourism is the island's main source of income, most tourists only come during the summer. Because there are so few residents during the majority of the year, access to healthcare is very limited, and people must fly or take a ferry to the mainland for treatment. Ocracoke's infrastructure can be simplified down into 5 domains of interest: land, air, sea, space, and cyberspace. We will be mostly focusing on the air domain, but we'll use the other domains to help build the sustainable infrastructure needed for it. Now, this is an ever-changing effort that we have worked to improve every day as the advancements in sustainability change.
In order to achieve a truly sustainable system around aviation on the island, the 5 domains must work together, mingled. We'll now discuss our ideas on the design for each of the domains on how a sustainable system can be introduced.
All right, so we're mainly going to be tackling the air domain today. To improve sustainable development in the air domain, our team first looked at the already existing infrastructure on Ocracoke Island, as it is one of the only ways to get on and off the island. Currently, Ocracoke has one 3,000-foot-long airstrip and one helipad with underdeveloped facilities. While developing this design, it is key to leverage already existing infrastructure and keep in mind the sensitive nature and limited land on the island. Ocracoke Island does not have advanced infrastructure for air travel. Therefore, there is more chance for adaptability and innovation in the implementation of environmentally compatible and sustainable infrastructure. With this in mind, our team thought that the integration of advanced air mobility, AAM, would not only be feasible on the island, but also a good model to follow for the rest of the country and the world in the decades to come. According to the Federal Aviation Administration, AAM refers to aircrafts that are highly automated and electric, which means air taxis or electric vertical takeoff and landing aircrafts, which I'll be referring to as eVTOL from now on. AAM advancement is currently focused on larger cities since it's more complicated to modify existing infrastructure and air traffic. However, since the island is an isolated model, implementation of AAM infrastructure would be more straightforward and concentrated. With this being said, converting to AAM infrastructure would reduce the carbon footprint created by air travel, and it would also decrease noise pollution, as electric vehicles are quieter than their counterparts that use fossil fuels. While our goal would be to improve air traffic and its accessibility and sustainability, it is key to keep in mind that we do not aim to increase air traffic outside the bounds of what is necessary for life on the island.
Well, what is necessary for life on the island, Daphne?
Great question. Implementation of AAM might be approached with resistance and doubt from the community of Ocracoke. Many islanders can only work for several months, depending on the season. Will this threaten their livelihoods? Will it cause more disturbances than there already are? The ferry is not perfect, but it works. Key word here, it works. How will implementing AAM help and improve life on the island in a tangible way, in a way that actually matters to the people there? Will it even work? Although the island's healthcare system has improved over the years, there are still major obstacles to overcome. Currently, the island has only one pharmacy that opened within the past year, one healthcare center, and a helicopter aid to help emergency patients to mainland North Carolina. However, there are no labs or hospitals. The island still heavily relies on ferries, and they don't run when there's fog or inclement weather, which is pretty common in Ocracoke. Given how important fast travel and dependability is important for healthcare, this is actually not that great. Accessing efficient and reliable healthcare is important to all of us. Medical care requires efficiency, reliability, and speed, and recent studies have shown that AAM can have significant benefits to healthcare, especially in remote areas, such as Ocracoke Island. One way to implement medical AAM is the delivery of pharmaceuticals and medical supplies through the use of drones. A study conducted by Bridgelal et al. In 2024 found that drones offer substantial advantages in pharmaceutical logistics, particularly in rural settings with dispersed populations and challenging road networks. Given that Ocracoke is an island, it is a challenging road network. The analysis of the study revealed that drones can become more cost-effective, highlighting their economic potential, and they can also lead to considerable time savings, improving the critical response time for this pharmaceutical supply chain. The flexibility of drones to handle smaller, more frequent deliveries, along with the geographic difficulties faced by the island, aligns with our focus on the modern sustainability goal of reduced emissions from electric drones. Use of drones can also quickly progress into eVTOL technology and take us to the next step of critical medical air transport, transportation of patients, medevac. By placing strategic vertiports by mainland North Carolina hospitals and airports and on the island, fast, reliable, and economic transportation of medical emergencies can be implemented, and through the successful application of AAM through healthcare, this can be a significant introduction and proof to the community to establish trust within them for AAM that this is not just a cash grab, and this can also be a great representation for the rest of the country in the decades to come. Now, I mentioned eVTOL a lot. Electric vertical takeoff and landing vehicle technology is a rapidly growing and promising technology within the AAM industry. Along with being sustainable, vertical takeoff saves a significant amount of land compared to horizontal airstrips. However, when discussing and recommending eVTOL as a possible solution, we must address the energy problem. Given that Ocracoke Island is only 82 miles from mainland, and current small electric aircraft can fly up to 150 miles, it is possible to connect Ocracoke Island and mainland North Carolina with electric flight, but only one way. It would not really be a round trip if we want efficiency and fastness, such as for medevac transfer.
Well, that doesn't sound too efficient.
Yeah, I know. This leads us to the battery problem. eVTOL batteries can't be just adapted from electric car batteries, lithium-ion batteries, that typically have steady drain rates. Batteries for eVTOL require varying amounts of power for flight stages, such as climbing, hovering, and descent, with some phases of flight requiring high bursts of power and inclement weather. Research conducted by the Oak Ridge National Laboratory, ORNL, has shown that lithium-ion batteries in the use of eVTOL face significant degradation after short uses, which poses safety threats along with increasing aircraft maintenance costs. Currently, the perfect, long-lasting, and high-efficiency eVTOL battery does not exist. However, many labs are working on alternatives that can last these high-intensity cycles for longer flights, for flights that can be on top of each other. This is where our solution offerings start. We offer hybrid options. Establishing hybrid electric vehicles would not compromise the use of electric vehicles in the future because infrastructure for hybrid vehicles would be the same for their fully electric counterparts. Hybrid options for now would be a temporary solution until fully reliable and safe electric options are available. In addition to this, in the way that they operate, batteries have good power density, which is good for high peaks during takeoff and landing, where liquid fuel has good energy density, which is great for continuous loads during flights. Speaking of energy sources, we also need sustainable ways to charge these batteries that we're talking about. As eVTOL technology develops, the demand for energy increases, and local electrical grids are not enough in their energy providing, and they are vulnerable to outages and disturbances. And given Ocracoke's weather patterns, again, it is very prone to disturbances. This is where further energy solutions come in. Battery energy storage system, which I'll be referring to as BESS. In a very simple explanation, they trickle charge from grids during low peak periods towards use for high peak periods. They can source 500 kilowatt hour energy, which can be enough for sustained flights. It also has features such as bidirectional flow, which can charge and discharge batteries, saving time and cost efficiency. It also has temporary, permanent, and mobile versions, which can be used as suited for the island's needs. However, there needs to be some sort of standardization across the country and in the world for batteries, their adapters, and companies need to come together and governments need to come together to talk about the standardization in order for this process to be smooth, streamlined, and harmonious. Now, for all this talk of infrastructure and energy to be possible, we need sustainable sources of energy. This leads us to the land domain.
So, as Defna was saying, you need to have reliable energy for a lot of our solutions to even be possible. Now, solar energy storage systems are crucial in the 21st century, and they make up a good portion of mainland US energy sources. Now, Ocracoke Island currently gets their power and their electricity across 82 miles underwater through a cable attached to mainland North Carolina. Now, you can kind of see how this is an issue because Ocracoke is an island. It happens that natural disasters occur and that causes outages and issues with the cable. So that's something we had to look at. Now, because Ocracoke is smart and they're really trying to preserve their island, they developed a microgrid. So we saw that and we looked at it and we were like, how can we make it so it fits the sustainability and the self-sufficiency that we want for the island? Now, the microgrid produces about 500 kilowatts per megawatt hour. And the current storage for the solar microgrid is 1 megawatt hour. Now, this sounds pretty great and all, but if you look at it in the current power usage at a time at the peak is 7 megawatts, you kind of see a disparity between 1 and 7. So the microgrid is primarily set up to deal with outages. Outages occur quite a bit at Ocracoke because of the unstable weather. But it is tried and tested that the microgrid works for the island. So what we were planning on doing is improve upon it and help it go towards what we want for the island and how to benefit the people. So there are really two main things we can do to improve the microgrid. One is to increase the number of solar panels. Now there are 365 days of the year, and although Ocracoke suffers from fog and rain and all that, 200 of those days are sunny. We need to be using that to fuel the island. Now, to be able to work with the residents, there are about 200 homes and businesses that are able to get the standard solar panel setup. Now, 200 homes and businesses, that's a lot of buildings. This is not including the historical buildings because we do not want to change the island like that. Now, it's a lot of money, $5,000 for a standard setup that produces 2.2 kilowatts. But going on to one of our other solutions is to work with the state and federal governments. There are examples in Arizona and Virginia where governments will help pay residents to put solar panels on their homes for exchange for the energy to be put into the grid. Now, Ocracoke is a small island. If we have the solar setup that we want to, we'll be able to make enough to supply for the island and put it back into the grid, so it's putting more sustainable energy not only on the main island, but also on the mainland. The second one is obviously the short term would be to store within the power grid, but long term, we would increase the number of Tesla batteries. The Tesla batteries right now, we have about 10 on the island for the microgrid, but increasing that amount would allow for us to reach that 7 megawatt very easily.
That's some great ideas, Savannah, but what does this have to do with aviation?
So like Daphne was saying, and how a lot of our solutions are built off of, especially the eVTOL, the progression of sustainable energy is often dependent on the availability and reliability of local power sources. When we're looking at applying it to the aviation, we have several different uses for it, but we need electricity for our solutions. So one of them would be supplying energy for the eVTOL aircraft. There and back. Having those batteries that we were talking about earlier in the presentation would allow for us to charge on the mainland and then charge again while we're on the island. The other thing is with, the pharmaceutical transportation we were talking about, we need energy to power the drones, and that's really something that's important. So although we can come up with an infinite amount of solutions, one of the biggest ones usually involves batteries and electricity to really take down on the fossil fuel stations that we're taking in. Because yeah, you can have electricity and you're pumping it into these electric aircrafts, but if that electricity is stemming from fossil fuel station, kind of counterproductive, if I gotta say. So making sure that not only we're supplying solutions, but allowing Ocracoke to be more sustainable and self-sufficient will help in so many ways. It would just be perfect.
Having discussed the energy solution for Ocracoke through the land domain, now we can kind of look at how eVTOL and aviation technology can be utilized through also the sea domain. Take it away, Sydney.
Transportation is the leading greenhouse gas emission sector in North Carolina. To decrease this and work in tandem with our sustainable aviation implementation, we propose hybrid ferries and later fully electric ferries. The latest push in this process was taken by North Carolina Clean Transportation Plan in conjunction with the North Carolina Department of Transportation. It was released quite recently, and it was a guidance document that provided a coordinated study and strategy for accelerating decarbonization in the transportation sector. With this study in mind, my team and I got to work on thinking about different ways to implement their vision for zero emissions. We started thinking largely with fully electric and hydrogen-powered ferries. While one day we would like to completely transition the island to fully electric ferries, we understand that small actions can create change. By starting with hybrid ferries, we can slowly introduce change to the residents while also taking immediate action. These proposed hybrid ferries would run on both diesel and electricity, then start later start to begin the transition to plug-in hybrid vehicles, then fully electric hybrids.
Now, how could we implement a change of this magnitude?
I'm glad you asked. So if we start with hybrid ferries, there are many other companies that have already tried to do this and places then have been successful. One I noticed recently was that Seattle, with the huge ferry system and very large ferries in comparison to Ocracoke Island, the transportation system there has been given funding and the go-ahead to start to create electric ferries and hybrid ferries. They are in the process of building 4 and transitioning 3. Other places like that are Wärtsilä, which is it's a Norwegian company, and they are trying to work towards fully electric ferries. They have actually already successfully made a few. They introduced 2 to the Borja Lake with the intention to have 0 emissions by 2030. By looking at these ferries that have been transitioned fully and are at 0 emissions, we can use these as a roadmap to try and change ours. Wärtsilä ferries lower cost and they have better vessel mobility. Wärtsilä is donating the hybrid converters, the energy storage systems, and the energy management systems. The specific vessel I'd like to look at is the 50-meter vessel that can have 45 cars and 150 passengers. They do have a smaller one and they do have a much larger one, but this one got my attention because Ocracoke Island's ferry is very similar. Wärtsilä has a 6-year timeline, and we believe with the proper go-ahead and funding that North Carolina could have the exact same one for not just Ocracoke, but all of the ferry systems along the coast. Now, how would we implement not just these hybrid ferries, but one day the fully electric ferries? Well, as we mentioned earlier with the eVTOL, we would like to make places for these ferries to dock where Ocracoke's Island docks are currently. Now, we have a terminal in Swan Quarter and we have a terminal in Cedar Island. These are your mainland terminals. They will take you to Ocracoke Island, where there's another terminal, a docking terminal. Ocracoke Island is very, very small, and we wouldn't want to introduce any new infrastructure that would mess with their environment, especially because they have many, many protected animals and plants. So we propose, after looking into Archer Aviation specifically, what they are calling their sea portals, which are dual charging stations for electric ferries, as well as the eVTOL that we mentioned earlier. By having this as a terminal for both, we stay compact and we can change the boarding system, but keep it in the same place as not to upend the residents and the vacationers' lives. As you can see in these pictures, to the left, there is the original terminals. They're pretty much wooden structures. I've been on a few before myself. They're pretty much the same all along the coast, and they work just fine. But the ticketing system is in person, and the lines start to fill up and rack up, and if you don't make it, you are stuck in the road. We propose the exact same thing Archer Aviation proposed, which is their sea portals. We think that the design they had is perfect fit for where we'd like to put it in those 3 positions that I showed you on the previous slide.
Having discussed the main land, sea, and air domains, we also need to utilize the rest of the majority of space. So,
in regards to the space domain, one technology that is currently being researched at Semper Sky is the Luna 10. The Luna is a satellite system that collects solar energy from space and sends the energy to various collection systems in the form of microwaves. Not the appliance, mind you. The Luna converts the solar energy to electricity and then to microwaves on board before sending them to their desired location. Currently, the plans for the Luna 10 are to be used to help build and maintain various bases on the moon. But this technology could very easily be used on Earth, and specifically Ocracoke Island, to collect and utilize this clean energy in areas where space for solar panels is scarce. In order to send electricity to Ocracoke Island from the Luna, facilities would need to be built which can harness these microwaves and turn them back into electricity. One benefit of having these solar panels on a satellite, rather than simply having them on the ground, is that the sunlight coming towards the satellite is much more consistent because it isn't affected by weather. And with the right orbit, it could even collect solar energy throughout the day and night. Another benefit is that the energy could be sent across long distances, as long as a receiving station to convert the microwaves back into electricity is built where you need it. We will be utilizing the BESS systems that we talked about beforehand to help power the eVTOL systems and store the energy from the Luna. Another way the space domain can help create sustainable aviation infrastructure is through the use of weather satellites. Satellites are extremely useful when tracking weather of any kind, and especially inclement weather, and would be especially helpful on Ocracoke, where hurricanes and other storms are such a large threat. Utilizing satellite technology could greatly improve the speed at which various infrastructure projects are completed and also help prepare for big storms and other natural disasters which could potentially destroy said infrastructure. Furthermore, weather satellites already orbit the globe and track weather, so simply utilizing the data from these satellites would greatly benefit Ocracoke by helping to predict storms and keeping weather patterns known. Overall, utilizing satellite technology will help to greatly speed up the process of converting Ocracoke to sustainable technology and will help preserve said technology after implementation. Satellite weather tracking can help especially with the eVTOL aircraft by preventing damage from inclement weather. The satellites would be capable of tracking weather over the island and in the Sound in order to help prevent the aircraft from being caught in storms. This would be especially helpful when utilizing the eVTOL to carry nearby patients to the hospitals on the mainland, because you wouldn't have to worry about sudden storms preventing you from reaching your destinations. As all these implementations of physical infrastructure take place, the consolidation of the cyber system can occur concurrently.
Now we're going to switch to the final domain, the cyberspace domain.
Yep. So the cyberspace domain can contribute to building a sustainable community around aviation through two approaches: the optimization of power supply and space and time utilization, and the online community bulletin board. Sustainable aviation can take two main forms: sustainable aviation fuel, or SAF, and electric aircraft. As was discussed in the land domain by Savannah, the increase in solar generation is critical to ensure sufficient power is available for electric aircraft on top of providing electricity to people for their everyday life. Because of its natural susceptibility to weather, optimization of energy storage is critical to be able to have aircraft ready for use when needed. This is achievable with the use of battery energy storage system, or BESS, discussed as before, and systematically monitoring the factors affecting power generation and consumption. BESS is a commercial off-the-shelf system that greatly reduces the concern of inconsistency in solar energy generation. A BESS can trickle charge itself from the grid during low use periods for the use during peak periods. A significant advantage of it is its resistance to storage capacity degradation and the bidirectional capability, making it possible to discharge aircraft batteries and conserve both energy and cost. With the BESS, a consistent, reliable power backup is available. Additionally, a mobile BESS, or MBESS, which is small in capacity, easily movable, relocatable, and is vehicle or trailer-based for ease of use, can reduce the need of infrastructure upgrades on the island. Factors that can affect power generation include weather and tide. Weather is a direct factor affecting the amount of electricity that can be expected from solar generation. A system can be built such that it constantly takes the most up-to-date forecast in order to yield a precise value on the expected energy generation from solar, and it optimizes the timing of charging the aircraft batteries or the BESSes. Power consumption for electric aircraft can be systematically estimated from statistics on the number of visitors to the island or such. For example, there are more tourists on the island during the summer, May to September. During this period, power consumption can be expected to increase from transportation, which the system will take into account for its optimization of energy storage management. In shifting the transportation to and from the island more sustainable, more room in time and space for sustainable air travel is desired. Sustainable air travel is not limited to electric aircraft, but also includes aircraft with sustainable aviation fuel, SAF. Electric aircraft have some shortcomings with their battery capacity, directly affecting their range and travel time, which may not always be sufficient. For example, the Ocracoke Island Airport is about 82 miles away from the Coastal Carolina Regional Airport, the closest passenger service airport. Today, a typical single electric aircraft has a range of 130 miles. This is not enough for a round trip between these two airports, and a conventional aircraft is more suited due to its greater range. In such cases, SAF aircraft can be used instead to minimize the climate impact. In determining whether electric aircraft are sufficient or SAF aircraft is needed, a cyber system can be utilized. For the travel of large numbers of people at the same time, ferries are more practical than aircraft. Ferries can also be electric, so given an operating schedule, a system can also optimize the charging condition, taking battery health into account as well. Additionally, the system can feature an electronic ticketing system for the ferries. The aforementioned power generation estimation from solar is only possible with forecasts. For better forecasts and consequently more accurate estimates, working closer with the data given from the satellite is important. The satellite can also be helpful in case of natural disasters, giving better ideas to the rescue team, for example, on which area within the island requires more immediate attention. In realizing all these, a sound online cyber system is desired. In addition to the features mentioned so far, the system can be enhanced and gain more support from the people on the island by also functioning as an online community bulletin board. The board can have a social impact on the lives of people by providing information such as the energy or electricity consumption on the entire island, amount of fish caught that day, and a number of tourists in a certain period of time. These kinds of information will allow people to make smarter and more sustainable decisions. The board will also include other helpful resources in case of an emergency like natural disaster. Thinking about the population on the island, only 20% are under the age of 24. In order to develop a community that is more vibrant and has a sustainable future, a bigger young population is desired. For this, an incentive such as a free communication fee or free internet or some sort can be made for any families with young people under the age of 24 moving into the island. Also, 18% of the population is over the age of 65, with the median of 46. This is comparatively older than the mainland US, and some backlash can be expected from the residents, especially of those older age, on the digitalization of the community. Therefore, in-person seminars will be held regularly to train residents, including the elderly, to become more familiar with the new online environment introduced.
Now, as I previously mentioned, we did come up with a small timeline for what we possibly thought we could do this in. We researched a lot and had many other comparisons of different technologies we used, but we figured that immediately off the bat, the online bulletin board could be the first thing brought up, and satellite weather tracking would not be far behind. This is because the satellites in use would already be up and we'd just be acquiring their data. BESS can be within 1 year. The hybrid ferry, which was proposed, would be within 3 years after researching other places. The AAM infrastructure can be around 5 years, and the fully electric ferry, which is one of the things we're aiming for, would be around 10 years, maybe even less after looking at other data. The Luna A10 can be around 15 years. The online cyber system is written at the bottom because this is something that will be spread out among every single thing we have. It'll be ever changing, ever growing, and its timeline is never ending and starts immediately. As well as this, depending on funding opportunities, the increased solar microgrid can be up and running within a year. This includes the Tesla wall batteries, battery energy storage systems, and storage panels.
Compliance and adhering to standards are paramount in ensuring the success of this project. All initiatives must align with permits and government regulations, prioritizing the well-being of the island's residents and the environment. This entails rigorous assessment of proposed projects to ensure they meet local, state, and federal requirements regarding environmental impacts, safety, and community welfare. Collaborative partnerships with regulatory agencies, environmental organizations, and community stakeholders are essential to navigate regulatory processes efficiently and uphold the highest standards of environmental stewardship. Securing investments for the plan, we must effectively communicate its benefits, aligning with stakeholders' interests while highlighting its resilience to climate change, boost ecotourism, and simulate long-term economic growth. Showing success stories and addressing concerns by incorporating feedback would emphasize our willingness to prioritize the people affected, because ultimately it's the people we prioritize. Maintaining transparent communications and celebrating achievements will sustain momentum towards a sustainable future, not only for Ocracoke, but everyone there who calls it home, and be a model for mainland US.
From the beginning, our goal was always to not just introduce so many new technologies to Ocracoke Island, but improve the way of life and keep it going for as long as we possibly can. Like Savannah has stated, the people are paramount to us, and everything that we have proposed is in an effort to improve their way of life and possibly use Ocracoke Island as an image of what we want everywhere else to look like. I grew up around Ocracoke Island every summer, so this is near and dear to me. I've been able to see how the island has eroded and how we could possibly change everything there. Getting into the Sustainable Island Design Challenge, our goal was 100% sustainable Ocracoke Island, and now that we've focused more on aviation, it's been a wild ride, but we would love to see our designs make change not just in the technological advancements side of the world, but for the residents themselves and for the good of the community and everywhere else that we could impact.
Well, we are so grateful for your time with us today, and we would now like to open the floor to questions. Thank you.
Hey, excellent job. As a matter of fact, I don't have to tell you that because every single one of these says great job. So, hey, the students have done a great job. Do they consider short takeoff and landing as well as vertical takeoff and landing aircraft to reduce electrical energy requirements? Anyone in particular want to answer?
We considered a lot of things going into this. We had so many different presentations as we went through, and it was ever changing. Our initial document had about 5 ideas for each domain, and it was very big. When it came to the aviation sector, we had a lot of ideas about air quality control as well. But when we took a class with Dr. Bradley, who's close to Juice, we were able to learn about eVTOL through different articles we researched, and honestly, that worked perfectly for us due to the size of Ocracoke Island.
In the end of it, the reason why we focused on eVTOL a lot was because we found a lot of research on it and we were focusing on it a lot, and it just fit our framework very well. But obviously there are so many things that we can do right now, and we need to fit within a 45-minute period, so that's why we mostly focused on eVTOL.
Yeah, Ocracoke already has a, landing strip and things like that. So we were primarily looking forward for the gradual development across time. They have a runway, we might as well use it. But eventually, the vertical landing and takeoff would be something that Ocracoke could use to reclaim some of that runway land and use it for more important matters.
Awesome. So the next one here says, amazing job. Do you all see nuclear power as a viable possibility for the island?
So nuclear power requires a larger space. We would absolutely be keeping the underground cable coming from the mainland, but putting a nuclear plant on Ocracoke would take up a lot of room that I doubt the locals would want to, give away. We're trying to preserve the sanctity of the island, and adding nuclear to the island would be a little bit too much, but taking energy from mainland North Carolina, who does supply nuclear energy to Ocracoke, that would absolutely be something that they can definitely talk about. And that's really moving away from the fossil fuel power stations and supplying more sustainable energy to Ocracoke.
While also researching some other battery options, I read an article about the development of nuclear batteries, something along the lines of that, and that was very interesting, but again, it would have been too long if we got into that. But yeah, there are a lot of nuclear options in
the same vein, it would have been similar to using wind power. We just don't have that space on Ocracoke Island. But like we said, one day, Ocracoke Island is just such a great place to start with because of its size and isolation. But one day we would love to expand out further and apply these other renewable energy sources.
Yeah, and what's great is nuclear energy, the reactors are getting smaller and smaller. So as that technology improves, it's something we can look at. And just for the rest of the crowd here, this is an iterative process. So the next group of interns will take this idea and improve upon it, et cetera, until we have a viable solution. So the next one says, nice presentation. Have you shared the final presentation with island residents? What do you think they will like and not like? Do you all want me to answer that?
I think that's up to you.
Okay. So in order to protect the interns, I was the one making liaison with Ocracoke Island. Hyde County is the actual name of the county in which Ocracoke within North Carolina exists. So I was able to talk to their municipality. I was able to explain to them what was going on. When I got them on the phone, they were very interested, and they loved what was going on, and they started talking about some of their initiatives that they've been doing already. But when I email them documents, I don't get a response. So, and they were kind of like, hey, I'm enjoying the view right now, or hey, I'm out sailing, or, so you really have to engage them in person. Like they are not hey, I'm going to sit down at this computer and look at a PowerPoint kind of community. They want you to get out there. So when I go, I'm going to go and visit them in a couple of months here. When I go, I'm going to show them the final presentation, even though I made a link to it available to them. I'm going to get their feedback in person and then bring it back. But we did get their blessing to look into the island challenge, but their feedback, we're still waiting on the finite details. So the last question I'm seeing here says, props to the studs. Do you feel that your plan could be applicable for other isolated island environments, like, for example, the Caribbean?
Absolutely. So one of the things that we were really looking at is tailoring it to the Ocracoke experience. We wanted to preserve the life and the culture that the island has. And so really some of our things would be a solution for other islands, but we really prioritize tailoring it specifically for Ocracoke, but also giving solutions for other issues later on. Like if we have a bigger island, smaller nuclear reactors would be more possible, and there's a lot more ideas we have, but we can apply them to other islands, but we were really taking in consideration specifically Ocracoke because the people are so wonderful and we want to make sure to respect their home.
Beyond that, there is also, especially for AAM infrastructure, we took a lot of examples from other countries. One was Korea for the Incheon Islands. There's a lot of process in Korea about establishing AAM infrastructure and eVTOL technology to the islands. And also Australia is working on this technology as well. They do want to move to, from what I've read, they want to move on to AAM by 2030. So it's a global effort as well, and looking at this technology and looking at global implementations, we think it's very applicable to the rest of the world, basically.
And of course, we also mentioned like the residents of Ocracoke Island, but another important residence is the sea life around, and we had talked about it previously, but short presentation. But similarly, Bald Head Island, lower down, very much a nature preserve for a lot of different creatures, and we wanted to make sure that our technologies wouldn't just affect the human residents, but also the plants and the animals. So the way it is now, I believe that it could be pushed to most of the barrier islands along North Carolina and one day to the mainland. It's not just an island project, but a world project.
Well said, well said. So I've got one more question here, and then I'll go into the polling. So how can my students get involved with something like this? Is it through Semper Sky? I guess I should probably answer that. Yeah. So the answer is yes, it is through Semper Sky. So this is a great time to take a moment to say thank you to Dr. Marty Bradley. Dr. Bradley does several different things, and he's actually in the crowd today. So if everybody could give Dr. Bradley a hand, I'd really appreciate it. So Dr. Bradley, his time is very precious. He could work on, he could help put forth bids. He's a professor at the University of Southern California, which we refer to as the real USC. And when he is at the real USC, he is teaching sustainable aviation. And I just want to remind everybody, these are rising seniors in college, undergraduate, and they are not getting classes that are strictly sustainability. They might get like a little bit here, sprinkles of it. So, I thought it would be a good idea to augment that with an internship program. We talk a lot about these future solutions that we want to do, and we design this and we design that. But the ones who will actually be executing this, you're seeing before you now, and you also have in the crowd a rising senior in high school, Mr. Damon Smithson. He is one of our interns as well. He just wasn't part of the Island Challenge. And I met him at a fall internship networking event that I was doing for our previous interns, one of which is a master's degree student at the University of Virginia, Mr. Jack Snoop Vietmeyer. So these folks right here really represent the future, and any ideas that we come up with, they're going to be the ones actually physically doing the work. So why not have them? So yes, flysempersky.com/internships. Yes, you can do this with your students. But Dr. Bradley has been really the key. I neither have I don't have the breadth or the depth to be able to teach at the level that Dr. Bradley does. So him coming in and helping me and being able to attend every class and listening to the future generations and how they see the world, that's been tremendous. So I'm glad you see it too. So thank you for that question. Now, we're going to move to polling at this time. So as a thank you, for being here, and also to help with the feedback to make the next generation of student better, we'd like to know a few things about the presentation. So the first thing I'd like to know, and let me see if I can pull it up here. Here's your barcode that you can scan to answer some of these questions. But did the presenters meet industry standards for quality and information available in their brief? So I believe, yeah, there we go. I think that's it right there. So, all right, good. We're getting some answers in right now. And had about 5 folks so far weigh in, so far so good. I'm going to move to the next question. It says, of course, it cuts off as soon as I try to press my little tablet here. But as a preliminary design review, for some of you who are systems engineers, PDR is what this is called. I just want you to bear in mind that I did not provide you any of the products that typically go with a PDR. But would you accept this project for further work and funding, or send it back for revision and additional review. Okay. All right, so right now the polling's showing mostly a yes, right? I can understand some of the apprehension, right? Because there's a lot more data. You need more math, to be able to really say for sure. But at the same time, preliminary design reviews can be multiple. You don't have to have just one. So you can have PDR2, and you can talk more about the design and say, okay, I like your general idea. Now give me some numbers. Give me some dimensions, give me, some aspects of things that are more nitnoid in detail, so I can appreciate that. The next question, do you think modeling and simulation testing would help develop a better understanding of sustainability planning? So it goes with the sustainable infrastructure panel that was just previous to the group here, where we talked about large language models and the ability to help with predictive maintenance, to let us know ahead of time exactly what parts to order, et cetera. When you are a small business and you are providing services for infrastructure, if you dedicate too many of your assets or your resources, specifically money, toward certain parts, pieces, et cetera, and you end up not using those, and you can't get your full value back for them, this is something that we felt was really important. So modeling and simulation can help with that, and being able to show other airfields or other localities, hey, if you continue doing what you're doing, here's what you're spending. If you invest in sustainable infrastructure now, yes, you spend a lot up front, but over time, look at what you're doing. So, all right, 100% on that one. Okay. All right, so all that being said, this is open to comments for consideration. Like, what aspects warrant further review? What would you test for in modeling and simulation? And what is the most important domain in sustainability planning? So we don't necessarily need to go into great detail about this, because I know this is kind of an open forum here. But one of the things we're seeing here is customer engagement. So obviously that's critical. It's been the theme in everything we've talked about today, right, is making sure that you go and talk to the inhabitants of Ocracoke and make sure that they're aware and supportive and have buy-in. So a lot of the ideas that you saw in here actually were things that I put in the products that I gave to them, the performance specification, and that information came from me interviewing several folks who live on Ocracoke Island. Full disclosure, my wife's family lives on the coast of North Carolina, and they grew up going back and forth to Ocracoke. They were primarily fishermen and farmers, and so we go there a lot. We consider it a second home, and so we get a lot of time to talk to people, even in the off season when all the tourists are gone. So some other things that I'm seeing here, economics, eVTOL, energy storage. Biggest challenge is social engineering. Can't disagree with that. Harmonization of standards. Yep. Quick medical evacuation method. The cost versus benefit for the local community. Yep. Economic incentives and impacts, financials. So yeah, these are all great considerations. Educating local residents. So we hope to continue these types of internships where we create an iterative process. And I'd like to thank Goshin Sinar for allowing us to have this subcommittee. And this enables us to get better and to continue to support the sustainable aircraft, such as electrified propulsion systems that EATS really does a great job of elaborating on in their symposiums. So let me see if there are any other questions. It looks like right now there are no other questions. So could you all please give the studs a round of applause? All right. So one of the things that you get when you're a part of Semper Sky's internship program, or if you're affiliated in any way, shape, or form, is you get metal wings. So we have some plastic wings for you all, acrylic. Hey, small business can't buy everybody metal wings, right? We got a ration, right? So you come by at the end here if you're in the crowd because you came in person, come get some wings from us, okay? And if you want some wings like chicken wings, well, it looks like we're not standing in your way anymore of being able to go and enjoy Las Vegas. So thank you very much. And once again, thank you to this panel and thank you to the studs here. Did an excellent job.